Money.
Don't be annoying. All right, two-digit number word problems. These are very specific. Okay. We're going to solve two-digit number word problems today, and you're going to see that it has a lot to do with what we did over the last thing, as far as writing the equations. All right, someone raise their hand and give me a two-digit number, make it up off the top of their head.
Kevin.
Quinlivan.
23.
23. Very good.
21. Too big.
23. What would that number look like with the variables? What if you didn't know Quinlivan said 23?
X.
20 plus 3.
XY.
That's going to come into play. Keep thinking that, Nico. XY. There you go. We're all over it. Cube-on. If we didn't know it, does everybody agree that 23 could be XY?
Yes.
Okay, we always use X first, Y second, and whatever.
C.
You believe it or not, guys, and write this down after it, it's going to be TU. That'll make sense once we do a couple examples. Trust me on that.
2.
Okay. What if we didn't know Sarah wanted, that she was thinking of the number 23? We knew it was T and U. Okay? How could we get
I just know.
23 if T is, well, first of all, what's the value of T in Sarah's example?
2.
2. What's the value of U?
3.
How could you make 23 out of 2, 3?
2T plus 3.
Well, you know that T is 2, so 2T would be 4.
Oh,
But
so
you're right.
T equals 20, U equals 3.
No.
Did you do addition?
But can it be?
Okay. What, Sean? Go expand on that. Think about Nico's kind of got on the right track with it too. What number would you multiply 2 by to get it into its right place value?
10.
10. That's what. Okay. So here's what we're going to do. How does that relate to algebra? It's 10 times the tens digit times 2. But then how do we get the 3 in
Times 1.
But what are we going to do? What are we going to do with this sentence to make it end up being 23? What operation?
Add U.
Plus the ones digit. And believe it or not, guys, that equals the number. 10 times the tens digit plus the units digit, or an old way. You guys know that ones digit and units digit are the same thing? You guys ever, in elementary school, did they ever call it the units digit?
No.
No, I think that's old. That's like even the generation before me. It's the ones digit, but they used to call it the units digit. So if I say units digit, that's the same thing as the ones digit. That's why we're using U for the units digit. Anyways, from now on, guess what variable we're going to use for the tens digit? T. And if your T's look like plus signs, put a little curved thing at the bottom of it. I had to do that when I started teaching because or you could use a capital T, that's fine. But I would put a little. And then guess what variable we're going to use for the ones or the units digit? U. Okay? I always use like a kind of a cursive U. Wasn't a very good one.
I had an amazing one on my paper.
Okay. So, pretty good. That is a good one. What's the number? What's the two-digit number? If T's the tens digit and U's the ones digit.
TU.
Nope.
2.
U2.
No, it's not the band U2.
Your and
Bono.
plural.
Guys, it's up here. You know it.
10. What?
10 times the tens digit
Oh.
Plus U.
plus the ones digit. That's the that's the two-digit number. Okay? These three things. Everybody put 3 little fingers up in the air. Come on, Henry.
3 bomb.
You have to write those 3 things down for every problem.
That makes a lot of sense.
Okay?
Wow.
You have to
So
write. You have to write those 3 things down.
So for 23, T equals
2.
22 times
10 plus U, which is 3, it makes 23.
Yeah.
Once we do an example, it'll kind of come together. Now, some problems. So yes, you have to write all that stuff down every time. Deal with it. Put a big old star next to where I have a big old star already.
Big ol'.
Sometimes the problems, and in our examples, only the third problem deals with this. sometimes they talk about the digits reversed. Okay, what would Sarah's number be with the digit
32.
reversed? 32. What would that be in terms of T and U?
UT.
Oh my goodness, Alex.
Think about multiplying and adding.
T
What would-
times 10u plus 10u plus 3.
All right. If it ever talks about the numbers with the digits
T
reversed,
plus 10u.
you got to go 10u plus t, and you would have to write that equals the number with the digits reversed. And once we do an example, you'll get there. So you might have that. All right. Let's do a problem like this. Define two variables. Write a system of equations and then solve it. You're going to see elimination. Elimination's probably going to be the way to do this. There's a lot of work involved in these, though. If you want to put that down and take good notes. You're so distracted. Thank you. All right, here we go. The sum of the digits of a two-digit number is 6. The two-digit number is 6 times the units digit. Find the two-digit number. What type of problem is it?
Addition.
What type of word problem is it?
Oh.
A two-digit number.
Two-digit number problem.
My goodness.
Everybody write. Does it say anywhere in here about the digits being reversed?
No.
You don't have to do the 10u plus t. But everybody write the 3 things down that you have to write down for all these problems. T equals the tens. U equals the ones. And then 10t plus u equals the number. You've got to write that down for every problem. T equals the tens, u equals the ones, and 10t plus u equals the number. Right now, guys, what's the tens digit?
0. T.
T. What's the ones digit?
U.
What's the number?
6.
We
What's
don't have a variable.
10t plus u.
It's right there. It
Oh,
says-
10t plus
The
u.
number.
Guys, what's the number?
10t plus u.
10t plus u. We've defined those things. Let's try to write the equations now. Everybody read the first sentence slowly and carefully. Try to write the first equation.
It's like a riddle. Inside.
Go ahead, Olson.
TU equals 6.
It does not say the product of the digits
Of
is
T
6.
plus U equals 6.
So the sum of them. So we're going to add them. Very good. T plus u equals 6. The sum of the digits is 6. Now, read the second sentence. Here's the hard equation. Slowly and stop after a few words. And try to write the second equation. Anybody write the left side of the equation?
I can. It's easy.
Cubon, what's the left side?
TU. T
Got it.
plus U.
I got it.
Yeah, it's so
What are the first 5 words of that sentence, Al? So that means the number is, right? What's the two-digit number?
Oh, 10t plus u.
10t plus u is the two-digit number, guys. So I'm going to write 10t plus u equals. That is this much.
Oh, this much.
6 times the units digit. How would you write the right side of that equation?
6u.
6u. 6 times the units digit. The units digit is, the units digit, guys, is the same thing as the ones digit. Okay? So it's 6u.
Oh, my toe.
Okay. This one is going to be elimination, except you have to put that second equation into standard form. Everybody subtract 6u's from both sides. 10t minus 5u equals 0. Okay? What would you multiply the top equation by to put it underneath the second equation so that something gets eliminated?
5.
5. You're going to make 5u's and negative 5u's we have at the bottom here. So I'm going to go 5t plus 5u equals 30. Don't forget to multiply that 5 by this 5 to the 6. Okay, add them together. Our u's get eliminated. Boom.
Put in substitution.
15t equals 30.
T equals those.
Oh, how convenient. Here's my question. Do these types of, do two-digit number problems, do T and U have to work out evenly?
Wait.
Can the tens digit be 2 1/3? Well,
Yeah.
that doesn't make any sense.
Well, I mean,
Can
no.
the tens digit be a 2
Oh, no, 10's digit can.
the ones digit?
Yeah, be a half, right?
That doesn't make any sense.
10 halves. 10 and a half.
So your number would be like 4, if I'm looking for 43 halves. Can't have,
4 and 3 halves.
that would be a 2-digit number.
Oh, okay.
They gotta work out evenly. So t equals 2. Now, I'm gonna use this equation to figure out what u is.
Oh, that would have been easy.
2 plus u equals 6. How many people got u to be 4?
Kevin, I got T to be.
Okay, what's the 2-digit number?
Took the scene crap.
We put in
42. Wait,
Eh.
no. 24.
24.
Oh, wait.
The 10th digit is 2. The ones digit is 4. You gotta put them together and say the number. So,
Oh, okay.
because the question says, find the 2-digit number. Now, let's see if it works out. 24, have we got that written down?
Yeah.
What's the
Yes.
sum of the digits is 6.
First sentence check.
The sum of the digits is 6, guys?
Yeah.
Okay, the 2-digit number, 24, is 6 times the units digit.
Check.
What's 6 times the units digit?
24.
Is the number the same thing as 6 times the units digit? It checks out as well. Always check your answers to make sure that they work in the problem. All right, let's try the next one. You guys are doing great. The sum of the digits of a 2-digit number problem without cheating and looking back. Everybody write the 3 things down you got to write down for every problem. Go.
I only treated them like the last thing, like 10t plus 2 equals the number. I forgot it equals the number. But that's okay.
Kev Zippet.
T equals 10, U equals 1, and 10 T equals 2.
Thanks for supporting me. Sometimes,
I got it.
do you ever wish you were a dog? No.
Don't say random things, McNulty. Get people off task.
You don't.
All right.
Sorry,
Hey, now read the entire problem and ask yourself, does it talk about the digits being reversed anywhere?
No.
Some of the digits of 2-digit numbers is 4.
No.
5 less than a 2-digit number is the same as 6 more than 5 times the
Yes,
sum of its
read
digits.
it.
Find the nothing but reverse. We don't have to do 10u plus t. Okay? All right, but now let's write the equations. The sum of the digits of a 2-digit number is 4.
T plus 2 equals 4.
T plus u equals 4. That's the first equation. That's easy. Now, the second equation, everybody try to write it. Read a few words at a time and try to write it. Here's my equal sign right here where the word is. Everybody think they got the left side written?
The left side again. Right side.
I was.
Briggs, what's the left side?
5 minus 10t minus.
Remember, less than things get switched.
Oh yeah.
So switch those things around.
10t minus u minus.
How about 10t plus u
10t plus u
minus 5 means equals. Look at, here's how we get that. 5 less than. Whenever I see 5 less than, guys, I write minus 5. Because that's going to be 5 less. And I'm going to write something in front of that. Okay? Whatever's mentioned next. So 5 less than a 2-digit number. Well, the 2-digit number is 10t plus u. We've defined that. So I'm going to throw that in front of the minus 5. There's my equal sign. Everybody try to write this part. Try to write the right side of your equation. It gets nasty and big, but you all can do it.
What is the sum?
The sum, it's digits. Is that TU?
That's product. I don't know why you continue to
I
write
don't get how to do that.
Oh, okay. I think I got it.
product.
Uh,
Sonara, what do you think?
Is it 6 plus 5u?
No, you're close though.
6 plus 5.
No, wait.
Variable?
Hold on. Go ahead, Briggs.
6 plus 5t plus u.
You get put parentheses around the t plus u. So say it the right way, Briggs.
6 plus 5 times quantity of t plus u.
Correct. And then again, when I see more than, I put the plus 6 at the end. Though with addition, it doesn't matter. So here's the way he said it. So it's 6 more than 5 times the sum of its digits. 5 times the sum of the digits is going to be t plus u. And there's 6 more than 5 times the sum of its digits. Now, with 2-digit number problems, it takes a lot of space because it takes forever to get these back in the standard form. So everybody distribute your 5 and move things around and get it into standard form. It won't take long. Okay? Try to kill 3 birds with 1 stone here. I'm going to subtract a 5t from both sides. I'm going to subtract a 5u from both sides. And then I'm going to add a constant of 5 to both sides. Boom! Chupinski, you get it in standard form yet? Cube on standard form? Let's hear it.
5t minus 4u equals 11.
Nice. 5t minus 4u equals 11. Excellent job, Cubon. Alex, what would you multiply this top equation by and throw it underneath the other one to eliminate? 4. So 4t plus 4u equals 16. Our u's are going to eliminate. T equals 27. Boom! I love when that happens. Notice 27 is divisible by 9. So the tens digit is 3.
Now I know.
What's the units digit? 1. 3 plus what makes 4? 1. So what's the number?
31.
31.
Checks out.
Hey, check it.
Check alert.
What are the sum of the digits 4?
Yeah.
Check. 5 less than the 2-digit number? What's 5 less than 31? 26.
There's only 2 numbers it could have been. Or 3.
Correct, you're right. 5 less than that is 26 is the same as 6 more than 5 times the sum of the digits. What's the sum of the digits?
20.
Sum of the digits.
31.
Sum of the digits. Times 5.
40.
6 more than that. Checks. 26 equals 26. All right, first one with numbers reversed. Okay? A number is 9 more than the sum of its digits.
Why would they do this?
If the digits are reversed, here it is. If the digits are reversed. Everybody write the 4 things down that you got to write down for digits reversed problems. 4 things down. T, U, 10t plus u, and 10u plus t, the number with the digits reversed. So t equals tens, u equals the ones, and then 10t plus u equals the number. And since it talks about the number with the digits reversed, you got to write down 10u plus t equals something like number reversed. Keep it simple. Keep it short. So when the problem talks about the digits being reversed, write that 4th thing down. Okay. Everybody read the first sentence and try to write the first equation.
Wait, so at the end, would it be, if the numbers were like t equals 4 and then u equals 5, would it be 54?
No, the 2-digit number would be 45, but the number with the digits reversed would be 54. But the original number would still be 45. Good question. Come on, who can write the first equation?
Oh wait, so we don't need the reverse on the first.
And the first equation doesn't talk about reversed at all. It's the second equation where the digits reversed comes into play.
Wait.
Come on, guys, try it. Nico, you get the first equation?
No.
Try it. Melita? 10t plus u. The number is. We know the number. It's written. It's staring at you right in the face. Whenever it says the number, you're going to write 10t plus u because that's the number.
Oh, then I got the right side.
Melita, keep going with the right side. You're doing great.
I got the right side.
9 more than the sum of its digits. I don't know why you're going to. It doesn't say 9 more than the number. It says 9 more than the sum of its digits. So that one you're not going to multiply by 10. So I'm going to go 9 more than, so I'm going to put plus 9. The sum of its digits, just t plus u. Is that right? 9 more than the sum of its digits. It doesn't say the number, it says the sum of the digits. Okay? Now, if the digits are reversed, the new number is. Okay?
So that's 10u plus 2.
10u plus t. If the digits are reversed, that new number is, so 10u plus t equals 3 less than 4 times the original number.
The original number is 10t plus t. Yeah! You
Okay.
gotta use parentheses.
So write it, McNulty.
Okay,
I got it.
10u plus t equals 4 times the quantity of 10t plus u minus 3.
4 times the quantity of 10t plus u, then 3 less than that would be a minus 3 at the end of it. What number, Kev, gets distributed?
Kevin, 4.
I don't know why I'm doing that equation first, but I'm going to.
The other one doesn't.
You know it, why not?
10u plus t equals 40t plus 4u minus 3. Okay? Move your variables over.
Wait, which version? The top equation?
The use case, that happens. We're going to deal with that in a second. Let's put I'm still dealing with that first equation. Guys, put things in the right columns because things got reversed here. 'Cause we're talking. So watch what happens here. You get negative 39t plus 6u equals negative 3.
This gets weird.
Does everybody see how I did that? You got to put your t's first because kind of like tu is kind of like x and y. So I got to put my t's first. Now, something weird happens up here. Subtract the u, subtract the t, subtract the u, subtract the t. Does everybody agree that the second equation was 9t equals 9?
Yeah.
Or excuse me, the first equation?
Yeah.
Okay. That one will only have one variable, so let's solve for that variable. Divide by 9. What is t in this problem? T is 1. We
What's
know,
your number?
we know that the tens digit is a 1. The number's in the teens. Okay? Since I know that this is t is 1, I'm going to substitute it in to the other equation for t. Negative 39 times 1 plus 6u equals negative 3. I'm going to add 39 to both sides.
U equals 6.
Okay? 6u equals 36.
What?
Briggs is correctamundo. The u equals 6. Briggs, what's the number?
It's a lot.
61.
You did it wrong, guys.
It's reversed.
It's not that hard to...
16.
Yeah, I think the digits reverse is 61, but the original, it says t is 1 and u is 6, so the number is 16.
Oh, find the original too.
Okay? Now, a number is 9 more than the sum of its digits. What's the sum of the digits of 16?
7.
What's 9 more than that?
16.
Okay? 16 is, the number 16 is 9 more than, that checks out. If the digits are reversed, what's the number with the digits reversed?
61.
61. The new number is 3 less than 4 times the original. What's 4 times the original? What's 4 times 16?
64.
3 less than that. Boom. It checks. We're good to go. Okay? So, 2-digit number problems. It's all about defining your variable. Variables. Okay? You got to write this stuff out. Tomorrow, no credit, guys, on your homework. You don't have that stuff written out.